to another past paper walkthrough. Today we're doing OCR C1 Core 1 Mathematics, and it is in the MEI section. So if you're not doing this particular paper, then do not just turn away, and I'll be wasting your time if you don't. So for this paper, you'll need answer booklet, which will be given in the exam. You can use line paper if you want right now, if you want to do it along as I'm talking through it. MEI examination formula and tables, which is the purple booklet that you'll have at the exam, so they will provide that as well. And you're not allowed anything else, not a calculator, nothing, just basic pen, pencil, ruler, and eraser, stuff like that. And yeah, so let's start looking through. So 72 is the full mark. You should always be looking to maximize this, because this is core 1. Core 1 is the easiest of all, so you should be trying to maximize whatever UMS you can get. So question 1 in section A, find the equation of the line with gradient -2 which passes through point 3, 1. Give your answer in the form y equals ax plus b. So first thing you know about this question is that it has a gradient of -2. You can highlight the question if you want in the exam. So a good way of maximizing your mark and try to prevent careless mistake is to highlight key points. So gradient of -2, which marks that y equals ax plus b. This is the general form of a straight line equation, and a represents m, which is the gradient. So essentially you know that a is -2 because it's given. So what you have right now is y equals ax plus b, and if you can write it as y equals to -2x plus b, because you know that gradient is -2, and also we know that it passes through point 3 and 1, so 3 is x and y is 1, so 1 is equal to -2 times 3 plus b. So by rearranging this equation, you can get what b is. So if you do it step by step, you can get that 1 equal to -6 plus b, because -2 times 3 is -6, and so b will be 7. So now you have the two values. You have a, which is -2, and b is 7. So you put it into y equals ax plus b. You get y equals -2x plus 7, and that is the answer to the first part. Now this question have two parts. The second part is find also the point of intersection of this line with the axes. Axes is the key word right here. It doesn't want you to find one axis. It wants you to find both axes. So you need to find y-intercept and x-intercept. How do you find that? Well, you know, when you have y-intercept, x is 0. And when you have x-intercept, y is 0. You can solve equations with that. Because you have this general equation, you can type if y is 0, then 0 is equal to -2x plus 7, and you rearrange that to get 2x plus equals 7. Then you can divide both sides by 2 to get x equals to 7 over 2. Again, you want to try to put answers in C1 as a fraction instead of decimal. It doesn't matter if it's recurring or it is a beautiful round number. As long as it's in fraction form, they won't deduct mark off you because it is accurate, and it is this very it's essentially important that you keep the accuracy up, since if you reduce the accuracy by turning something into decimal, say a third, then you will lose mark for it, because mark schemes are picky like that. Now you've got x is equal 7 over 2 and y is 0 in that case. So in this you have the x-intercept at 7 over 2. Now we need to find where the y-intercept is. So we put that x is equal to 0, and so y will be equal to 0 plus 7, which is obviously 7. So now you've got two values. They are not on the same point though, so you need to make sure that you know that this is separate from this. So you've got a data point right on the x-axis, (7 over 2, 0). This is the x-intercept, and on the other hand, you've got another data point 0, 7. That is the y-intercept. So you have to label these two as clearly as your final answer. Sometimes people do a double slash next to their answer to mark it as final answer, so that the marker can see which specific place to look for the answer. Okay, so you've got the first 3 marks on that, and now go over to question 2. Let's make B the subject of A equals that. Okay, so this one is quite simple because you know that you have to divide both sides by something to make it so B is the subject. Well, the thing right here, the tricky part, is the B squared. I'm sure you guys can move 2 over 3 and C over to the other side by reverse engineering. So by multiplying both sides by 3, you eliminate this 3 on the bottom, and you divide both sides by 2 to get that this number term is gone to the other side. So it's 3 over 2a equals b squared c. So I'll type it out. Nope. A is equal to 2 over 3 b squared c. If I'm right about it, A equals 2 over 3 b squared c. Yes, that's right. So first, multiply both sides by 3. So 3a is equal to 2b squared c. And now divide both sides by 2, so you get 3 over 2, or 1.5a. Well, this is a terrible idea. I'm sure you guys know what I'm doing, but when you're typing, you need to make sure that the brackets are right, because it can make a mess. Yeah, so 3 over 2 times a is equal to b squared c. And now next step, what you want to do is divide both sides by c to eliminate the c term, so that you get we've got this, and divide by c now, and this goes away. So you have essentially divided both sides by c. Yeah, this term is just stupid, isn't it? I regret typing this in a computer. And now we've got a b squared term. Well, first of all, before we do anything with the b squared term, I want to fix the problem of things being so disgustingly bad, ugly. I'll try to handwrite stuff out so that it's a bit okay, that's better. Is equal to b squared. To be honest, that doesn't look any better, but oh well. Yeah, so basically this step is nothing. I did nothing there. I'm just rewriting it to some easier to understand format. So you've got a fraction 3/2 and the fraction a over c. They are multiple of each other, so basically you can link those two lines together. Yeah, why not? I'll link those two lines together. Yeah, so this is one fraction equals b squared. Now we need to do something to both sides to make this into single b. How do you do that? Well, if you know how to reverse a square, you root it. So you do a square root. So both sides square root, so you get square. That is a very disgusting square root. I have to admit, that is terrible. 3a over 2c is equal to b. And if you're OCD about it, you have to put plus and minus in front, because whenever you do roots, you don't know if it's a positive number or a negative number. But in this case, if you leave it in this format, then you'll get the mark. So that's that. Excuse my terrible ability to write on the computer. Well, okay, so we've got 3 extra marks. Now go to question 3, evaluate this fraction. So this is all about index law, and index law state that if you have a power that is negative, you do 1/, which is the reciprocal of the number. So you swap the denominator with the numerator to get 5. Then now you get 2. So 5 to the power 2 is essentially 5 squared, which is 25. So the first part is 25. Second part is that you evaluate 8/27 by 2/3. So now right here it is admittably tricky that a lot of people can't do this because they're not familiar with fraction powers. But all you need to know is that the denominator of the fraction, the 3, is a root. So you do a cube root for this value. I find it incredibly easy to do the root before you do the power, because you are dealing with smaller numbers, and in this case you just do not have a calculator for this, so you have to use the simplest way. So you cube root everything. 27 we know is a 3 cubed, 8 is a 2 cubed, so you get 2/3 to the power 2 after you've cube root the value. So 2/3 squared, you index law, put the power into the value, so you get 2 squared over 3 squared, which is 4/9. So number 2 is 4/9. That's the answer. Okay, now go to question 4. You have to factorize expression, and that looks kind of meh. It's not that hard, but so first thing first, in this it wants you to factorize it and hence simplify. So you do not do the simplify first, you do the factorize first. So first term, x squared minus 9. This looks incredibly familiar. If I say that 9 is 3 squared, you will definitely know a law that is called the difference of two squares. So the difference of two squares makes it so that x squared minus 9 will become x plus 3, x minus 3. So that is the first x plus 3, x minus 3. Let me write that down. X plus 3, nope, x minus 3. So this is the top term, denominator. And now go to the denominator, x squared plus 5x plus 6. If you're good at this, you will know that it is made from 2 and 3. But if you're bad at it, then you need to practice how to factorize some stuff quickly. So by looking at this, I know that this is x plus 2, x plus 3. So we've got x plus 2, x plus 3. And now here, this is a fraction, so you'll put a line through. Now you'll find something incredible, that x plus 3 have occurred both times, so you can cross out and you'll get the simplified answer, x minus 3 over x plus 2. And that is the final answer for this 3-mark question. Now, down to question 5. I've been kicking a board under my table for quite a few times. If you hear something, my bad. Okay, now you have to simplify 10 root 6 cubed over root 24. This look a bit awkward, but yeah, let's break it down a bit and have a look. So what you need to do in this situation is to keep calm and try to factorize stuff out. You know that you have a cube here, so it's essentially a root 6 cubed, but you can break down root 6 into root 2 and root 3. So it's a root 2, yeah, it's a root 2 cubed times a root 3 cubed. Down on the bottom, you know that 3 times 8 is 24, and you know that 8 is 2 cubed, so when you square root this, you can factorize the 2 out to, oh my god, this question is probably one of the hardest I've seen on a C1 paper. Can I copy this? Nope. Okay, I'll just have to copy this thing. 10 root 6, I think. Yeah, 10 root 6 cubed. And it's over root of 24. Right, so let's do it one by one. Sorry, I've been disrupted. Okay, so let's do it one bit by one bit. Root 24. You can do it as, well, 24 is equals to 2 cubed times 3, so 8 times 3. And so you know that you can factor out a 2 squared out of the root 2 to get that root 24 is equal to 2 root 6. Okay, now this is something interesting because we've got a root 6 at the bottom and a root 6 on top. So now what you need to do is replace root 24 by 2 root 6 because we have factorized it. So let's do this. Okay, now we have got a 2 root 6, and now we can do some cancel out. 10 and 2 can cancel out to get 5, and root 6 can cancel out. Remember, this is a cube, so now it turned into a square because index law. And now the final answer will be 5 root 6 squared. And you'll find out that when you square a root number, you get the number itself, so you get 5 times 6 and you get 30. That is the answer for part 1 of question 5. So now part 2, simplify 1 over 4 minus 5, 1 over 4 minus root 5 plus 1 over 4 plus root 5. So pretty typical. You need to find the common denominator, which is 4 minus root 5, 4 plus root 5. And so the first term will become 4 plus root 5 over 4 minus root 5, 4 plus root 5. This will be a pain. Okay, so I hate so much. 4 plus root 5 and 4 minus root 5. That's the first term. And you have to multiply it by another 4 plus root 5. Yeah, I missed out the bracket. A bit better. Yeah, so this is a addition, so you add a 4 minus root 5 because after you've factored this, you multiply both the top and the bottom by 4 minus root 5, so that 1 times 4 minus root 5 is 4 minus root 5. So you add a 4 minus root 5 here. 4 minus 5. And this is incorporated, and now you need to simplify the top. So what you need to do here is 4 plus 4 is 8 plus root 5 minus root 5. Oh, well, this we know can be cancelled because they are the opposite of the same thing. One positive, one negative, and they cancel out to 0. So you get 8 over this beast. Oops. Well, now we've got this very largely simplified thing, but can we simplify it even more? I do believe that we can. So now what we need to do is to abuse the law of difference of two squares, we know that 4 minus root 5 times 4 plus root 5 is 4 squared minus root 5 squared, which is 16 minus 5, so we get 11. Well, okay, 16 minus 5 equals 11, so we get that the answer to this question is 8 over 11, and this is the final answer of that one question, which is incredibly not unsatisfying, because I thought it's gonna be a good number, good even number that you can cancel out further, but never mind. Okay, question 6.1. Evaluate 5C3. Now this is a choose 5 choose 3 function, and if you did listen in class, I'm pretty sure you've been taught this. What you need to do in 5C3 is 5 factorial, there we go, 5 factorial over 3 factorial times 5 minus 3 factorial, which is 2 factorial. So in this case, you might think, oh, this will be a terrible day because I have to multiply all those numbers, but not really. If you put them into their factor form, 5 times 4 times 6, 3 times 2 over 3 times 2, then multiply by 5 minus 3 is 2 factorial, which is only 2. The one I removed just for the simplicity, and you can do something cancelling, so 3 cancel out 3, and 2 times 2 is 4, cancel out 4, so you get 5 times 2 is 10. So the answer is 10. Or there is another way, that is, you can remember 1, 5, 10, 10, 5, 1. This is the Pascal triangle of order 5. This is power 5, and you will find the third one, 1, 2, 3. 5C3 is 10. It's not Pascal triangle is essentially the same as this function, so if you really can't, then you can draw out the Pascal triangle and count it upwards, but that is a terrible idea. It will take you a long time if it wants you to do something like 10C7 or something. That would take you a while. So that's this part. Now part 2, find the coefficient of x cubed in the expansion of 3 minus 2x to the power 5. MEI OCR papers are obsessed with binomial expansion, which I know it is a good question, but it's largely not essential. Okay, so 3 minus 2x power 5, that's the question. It is. Now we need to find third coefficient. Well, again, binomial expansion uses this term. So what you do is 5C 5C3. I got the hotkey right for once. Then you do the first term, which is 3 to power 3, and you multiply it by the second term. Remember the negative sign, power 2. This will yield you the third term. If you know binomial expansion, which you will, then now we need to simplify this. We know that 5C3, this 5 should be a superscript, but I didn't do it, so when you're writing the paper, please do, because you can lose mark that way. So this term is 10, then you times 3 cubed, which is 27, and you negative 2x squared is 4x squared. The problem here is that it wants the coefficient of x cubed instead, so that's my bad. That's not right. It is actually this power 2 and this power 3. But the thing about the coefficient is that despite this being, well, it does make a difference. Oh well. Okay. So now we're using 5c2 instead of 5c3, which 5c2 is 5, because Pascal. Is it? No, it's not. 5c0 is 1, c1 is 5, 2 is 10, 3 is 10, so this is still 10. It's 5c2, but it's 10. So 5c2 is still 10, so we've still got 10 times 3 to squared is 9 times negative 8x cubed. And now you multiply them together, 9, 8, 72, 720. And remember, because it's negative, remember you have to negative 2 to the power, it have to include the negative sign. If you don't, then you're in trouble. So 720 is the coefficient of the x cubed. So that's 4 mark right there. It can be tricky, but you just need to know how to do binomial. This is a very typical C1 question, and I will suggest you to revise that. Now, question 7, find the standard value for k that the graph y equals x squared plus 2kx plus 5 does not intersect the x-axis. Well, this is, again, graphical question that uses the fact that you have to know something about the quadratic equation. These are all quadratic equations, but in this case, it wants you to use the quadratic formula. In the bit that describe the graph, there is the formula is negative b plus or minus, how do I type that on the computer? I don't know. Plus or minus, I'll just add it later. Plus or minus the root of b squared minus 4ac over 2a. Okay, so that's why I added my video before I do stuff. Okay, so now I've got this beautiful beast equation. This is the quadratic formula, and we're interested in this bit, the root bit. So the thing about crossing axes, if you do enough math, you will know that if a graph crosses the x-axis, that means those are the solution to the equation equals 0, or the root of the equation. But in this case, it says that it doesn't intersect the x-axis, which means it doesn't have a root. Strictly speaking, that is not true, because they have roots. They are imaginary, which you still don't know about if you're doing C1. So essentially, it doesn't exist. This value this root value doesn't exist in that case. So how can a root value not exist? Well, if you've encountered or if your teacher have demonstrated this for you, you know that sometimes stuff like this, oh my god, god damn it, okay, something like this can exist, the square root of a negative number. There just aren't a solution to this, because any number squared will be a positive number, and so you can't root a negative number because it doesn't make nothing makes up a negative number by squaring. This is one very fundamental rule that you have to remember, is that if this part b squared minus 4ac is negative, there aren't a solution. And so you have to look at this equation and find b squared minus 4ac. So b squared in this case is 2k squared. So we've got 2k squared minus 4 times 1 times 5, which is 4k minus 20. So in this case, it told you in the question that it doesn't intersect, so we can draw an inequality that it is smaller than 0. It looks disgusting, but oh well. It's smaller than 0, so you do inequality equations by rearranging, so you get that 4k is smaller than, I'll just type it out, 20. There we go. It's smaller than 20, and so you divide both sides by 4, and you get that k is smaller than 5. So this is the answer for the question, when does it not intersect? Okay, so yes, so you find a set of value which is any number below 5. So you've solved this question. Now the function of fx is x to the power 4 plus bx plus e. So that function of 2 is equal to 0. Well, if it gives you this, you know, whenever you see this, you know that 2 is the root, at least one of the roots. And because of factor theorem, you know that if you put a factor into the equation, you get 0. So when it is divided by x plus 3, the remainder is 85. Again, remainder, when you see this, you know you want to use remainder theorem. And those two are essentially the same. You substitute this number into the equation and you get you get the remainder as the solution. So what you need is a simultaneous equation in this case. Well, first let us find this. X to the power 4 plus bx plus c. This is the equation given, and you want to find that f of 2 is 0. Nope. This is better. And f of, well, f of what? Because it gave you x plus 3. Well, you know, if it is remainder theorem, then you find that if this number is 0, it will give 80. negative 3 is equal to 85. Yes, so now we need to find B and C. Okay, so F2, so 2 to the power 4 is 16, plus B times 2, so 2B, plus C. That's the first equation, and this equals to 0. And now 85 is equal to negative 3 to the power 4, which is 81, minus 3x, and 3b, plus c. And here, if I didn't do anything wrong, which I do not think, yes, okay. So now you can do some cancelling down bottom, so that it's 4 equals minus 3b plus c. Makes it a bit simpler and easier to look at just by subtracting both sides by 81. And now you can do something called subtraction method. You subtract this equation by that equation, or the other way around, because we both have plus c terms. Okay, never mind. I am a goon and I can't use my computer. That's embarrassing. Okay, so by subtracting, you know that 4 minus 0 is 4 equals 0 minus 16, because there aren't a constant term on the right, so it's negative 16. Negative 3 minus plus 2, which is negative 5b, and c minus c is 0. So now we rearrange to get 20 equals negative 5b, and so b is equal to negative 4. After we've found this, we can use this number to get the answer for c by substituting 2b by negative 4, well, b by negative 4, and get that 2b is negative 8. So 0 is 16 minus 8, if I can type, plus c, and you can see that 16 minus 8 is 8 plus c, and if you subtract both sides by 8, you get c. So c is negative 8 in this case. So now we've got b and we've got c, which answers the question, find the value of b and c. So we've got 5 marks, just like that. Now question 9 is a bit awkward. Okay, this is a proof type of question. So what you need to do right here is to notice that you need to simplify this term, but again, when you see two squares subtracting each other, it goes directly to the difference of two squares. Can't even cancel things out today. Right, so n plus 3 squared minus n squared, I believe. Yes, so now we need to simplify this thing. First of all, difference of 2 squared, so you get that it is n plus 3 plus n, and n plus 3 minus n. And so you get that 2n plus 3 multiplied by n minus n is 0, plus 3 is 3. So 3 times that, and you get that 3 times 2 is 6, and plus 3 times 3 is 9. So 6n plus 9 is the answer. Now explain why when n is is an integer, that this value is never even. Okay, so there are two situations when n is even and n is odd. So there are two situations. Let's look at the first one. N is even. So when n is even, 6n is even and 9 is odd. So when OCD. So because 6n is even, 9 is odd, we know that an even number add an odd number will always yield an odd number. So sum equals odd. So it's not even. This is proven for the first one. So put a tick. Now we need to do n is odd. So 6n, is it odd or even? Well, we know that we're multiplying an even number 6 by an odd number n. So even multiplied by odd always yield even. And 9 again is odd. So therefore, same reasoning as the even n, the odd n have a sum of odd. So it can't be even in both cases, and a number can only be even or odd in this situation. So this is proven, and sometimes people write QED beside it to show that it is proven. And now, given that it is divisible by 9, what do you say about n? Well, now, if this is divisible by 9, that means you can take a 9 factor out of it. Let me make some room. Okay, so if you can factorize it by 9, then you know that 9 is a factor of 9, given pretty much the definition of 9 is a factor of 9. But then you have to say that 6n is a factor as well, because it can be divisible by 9. So what is 6n? It is actually 2 times 3 times n. And so since we have a 3 is equal to 9k, say, 9k is essentially 3 times 3. And so we know that both sides contains 3. And so that actually, as long as n is a multiple of 3, this holds true, that it can be divisible by 9. So the answer to this question is that n is a multiple of 3, since since n have to be divisible by 3k. So yeah, k can be any number, so that 2 doesn't mix with 3, it mixes with k, which doesn't change the fact that it is not related to n. So as long as n is 3, it can n is a multiple of 3, it can be divisible by 9. So that is the answer to that part. Now question 10 is a geometry question. Okay, a sketch ABCD. Show that AB is equal to BC. Well, a bit of coordinate geometry, which I love. Not. Okay, AB 1, 5 and negative 1, 1. Is it 1, 5 or am I? Yeah, it is. 1, not 1.5, it's 1, 5 and these 2 points. So let's look at the difference of x value. The difference of x value is 1 and -1. You do the large subtract by the small one, so that you get 1 minus -1, which is 2. Now difference of y is 5 minus 1 is 4. That is obvious. Now we can do a conclusion that it goes horizontally by 2 and go up by 4. And so because it is horizontal and vertical, we know this is 90 degrees, and so we know that the length of this, if I can draw a straight line, which I can't, is Pythagoras Triangle. So the root of 2 squared plus 4 squared. And again, OCR seems to be very obsessed with 2 squared and 4 squared, because it always goes to root 20 for some reason. Yeah, oops. Yeah, they love root 20 for some reason, and I have no idea. Okay, so now we've got AB root 20. Now we want to find BC equal root 20 as well, but we do not know, so what do? Same process holds true. So now we've got root 20 as the important bit that we want to keep. Now we look at well, we want B and we want C. What's C? 3 -1. 3 -1. And so we've got these 2 points. Again, we find the difference. The difference of this x is 3 minus -1, which is 4, and the y difference is -1 minus 1, which is -2. Now you'd ask, why would I use negative length, and how do I use it? Well, it doesn't matter, because we're doing a straight length. We are not concerned about the direction, and so you can see that as 2. So now again it's 4 squared, 2 squared, which is root 20, and you have to write the same thing again to show that equals root 20. And as well, it's a good practice to write 3 minus -1 and equals 4, and 1 minus -1 equals 2. These type of step have marks in them, and if you're lazy about it, then you might lose mark by not writing obvious stuff. This is just how examples work, which no one actually liked them. Okay, so now we need to show that diagonal AC and BD are perpendicular. Okay, AC and BD. So we do the same thing. We want to find the gradient this time, because we know that perpendicular gradients are negative reciprocal of each other. So AC, 153 -1, 153 -1. Yes, and BD is -1, 1. And 11, 5. Okay, now we need to find the gradient of this one, which is the difference of y over difference of x. So the difference of y in this one is 6. Again, write down the steps. I'm just lazy about it because I'm not sitting an exam, but you guys need to. This one, the sign actually make a difference. So we're doing 1 minus 3, so -2 x difference. So in this case, you do difference of y divided by difference of x, which you get -3 as your gradient. Good practice to label stuff and 1 to show that that is the gradient of the first. Now, again, do the same thing. 5 minus 1. This time I do bottom subtract by the top. 5 minus 1 is 4, and 11 minus -1 is 12. And here we know that 4 divided by 12 is 1/3. Hopefully you do, because if you don't, then you should revisit how to calculate basic numbers. Yes, so we've got the both gradients, and to show they're perpendicular, you do M1, M2. You multiply both numbers, and you should get -1. And you show that in step, that -3 times 1/3 is -1, and you can prove that it is perpendicular. Now, 3. Find the point of AC, a midpoint of AC, and show that BD bisect AC, and AC does not bisect BD. Oh, this is getting to be an extremely annoying question. That's why I hate coordinate geometry. It's just a waste. Well, it's good practice. Well, not good. What? Okay. It's a good idea to keep these value handy so that you can use them in other portion of the question. So find the midpoint of AC. Well, now we need to find AC again, which I foolishly deleted. But you know what? Power of editing. AC is this one. 6 and -2 is the distance. So we know that it goes left by 2, go up by 6. So if you halve those values by finding the midpoint, say this one, you have half of 2 and half of 6, which is 1 and 3. So you essentially went -1 and +3. And this is the movement of that point. So you translate that, the original point, this point, which is, in this case, should be 3 and -1, and you add this by this, and you'll get that 3 minus 1 3 minus 1 and 3 minus 1, okay, is the point that you're concerned. So this point is 2, 2, and 2, 2 is the answer of the midpoint, and you have to show that the equation of BD cut through that point. So the equation of BD, we can use the equation, the gradient, and use the straight line general formula y equals mx plus c, where in this case m is m2, which is 1/3, plus c, and you substitute the value of one of the point B or D. I'll choose B. So we've got 1 equals 1/3 times -1 plus c. So c will be 1 1/3. so it's 4/3. Okay, so we've got this equation, and we have to show that 2 lie on top of this. So let us try. When y is, well, let's see what y will be when x is 2. So y is equal to 1/3 of 2 plus 4/3. So that would be 2/3 plus 4/3, which goes to 6/3, which equals to 2. So since when x is 2, y is 2, we can show that it meets the midpoint of AC at 2, 2, which is the midpoint, so it bisects. So it is a perpendicular bisector. But now we need to show that AC does not bisect BD. Well, we know where AC and BD meet. They meet at 2, 2. Now all we need to show is that BD's midpoint is not 2, 2, which is relatively simple. I'll remove some things for my space. Okay, so midpoint of this, you have these two values just like you do here, and you get that the difference is +2 and +6, x and y, that is. The top is the y, so you want to do 1 + 2 and -1 + 6, because we're using the smaller value to add the distance on. If you're confused, try to plot a sketch graph and you will see how it's done. That will give you a coordinate of 3 and 5, and that will not be 2, 2, and will that means that AC does not bisect BD. Okay, that's 5 marks. Question 11. Oh, question 12. Oh. Okay, this is a pain. Graphics. 11. Cubic curve has the equation y equals fx, and it crosses at -½ -2 and 5. So you need to write down a linear factor. Because it's a cubic, you know there are 3 factors, and it essentially gave you the 3 answer. And what you need to do is that to show it is the formula will always be is it y or well, in this case you'll say y, because yeah, it gave you y equals fx. Y equals that, and if sometimes they don't give you that it is y equals fx, you write fx equals that equation, so that you don't get cheated on or something. Okay, so -½ x. Wait, this is, well, x equals this, so when you want to find the factor, you want to make it so the bracket equals 0. So rearrange this to 0 on one side means that x plus ½ is the root. So it's not negative, it's plus. Then you multiply by the other one, which is +2. I can't type. And x minus, I think that's 5 if I'm not is the factored format of the equation. Now you need to write down the equation, which you need to expand the stuff, which is always a joy. Okay, so x plus a half, 0.5, I'll write. And let's expand the back side to x squared. Minus 5 plus 2 is minus 3x. Then minus 5 times plus 2 is minus 10. And now you do x cubed minus 3x squared plus 0.5x squared and minus 1.5x minus 10x. Then you do minus not minus 5, that is. Hopefully I didn't do arithmetic error, because that would be very embarrassing. 1, 2, 3, 4, 5, 6, 6 terms make sense. And so you get x cubed minus 2.5x squared minus 11.5x minus 5. And because it wants you to put it in terms of y equals 2x cubed, you have to multiply this equation by 2, which is mathematically elegant to do so. So y is equal to, in this case you do not multiply y by 2 because first of all it is an equation that it only gave you the roots, it didn't tell you the y-intercept, so it might as well not be just this equation. So you multiply 2 to x cubed. So essentially you can confirm that y is a constant on this side right now. Minus 5x squared minus 23x minus 10. That is the answer for that part 1 equation. Now we need to sketch the graph, which is part 2. Well, sketching always is fun on a computer because you can control your cursor. But that looks quite good. Okay, first draw the axis always, and this is a cubic, so you use the general cubic shape and make sure that there are 2 roots at negative half, negative 2. So negative 2, negative half. It's not on scale, so since it's a sketch, you don't need to care about it. And this is 5. So what you want to do is do something like go up through this root, down through another root, and up on another root. And you can confirm that this is right because this intercept is negative and the y-intercept supposed is negative, so that is right. So this is the sketch. Remember to label axis, x and y, always write those down. And yeah, write down 1, 2, 3, 4 different point of intercept. That is the key. Part 3, the curve y equals fx is translated by 0, negative 8, which means it goes down by 8. State the coordinate of the point that intersect want the y-axis. Right, so it wants the y-intercept, which we know right here, the y-intercept when x is 0 is -10, but when it go down by 8, you subtract this value by 8, so that you get -18 as your answer. So -18 is the answer to the second part. And you ask, how is this so easy? Well, look at the mark, it's just 1, so it's supposed to be easy. Now question 4, the curve y equals fx is translated by 3, 0. Find the expression in factorized form for gx. Now, this is a bit more tricky because we're doing something with the graph. So when you translate a graph horizontally by 3 to the right, in this case, if you remember in function transformation, which you have done probably in GCSE Further Math or this year, you will know that if you translate fx, which I'll type f of x to the right, will become x minus c, and c is the factor of which it moved. So in this case, this graph moves right 3, so f of x minus 3 is what you want, and so in each of these factors you put x minus 3. So in this case, the first factor, which was x plus a half, becomes x minus 3 plus a half, which is x minus 2 and a half. How do I type that 2 and a half? Well, 2 and a half is 5 over 2, isn't it? So that is one factor, and you have to multiply this by 2 because we did a 2x cubed at this end, so it's essentially 2x minus 5, which is mathematically more elegant. Now x plus 2 minus 3 is x plus 1. That doesn't need explanation, does it? And x minus 5 minus 3 is x minus 8. So now we have 3 factors, and these 3 factors are the answer to that translation. So, and state the coordinate of the point where the curve intersect the y-axis. So now you want to find the y-axis, which means you want this x to be 0, which is quite simple because you can just do write out -5 times 1 times -8, which is 40 is the intersection point. Right, so yes, that goes. Oh, perfect. Graphs. Okay, now this is the last question on the paper. So now draw accurately on the copy of that the graph y equals x squared minus 4x plus 1. Wow, that is a tall order. I want you to draw accurately a quadratic graph, which okay, so in this case you want to do now I would So you've got this equation. I'm not sure if I can copy this thing. Probably. Oh, I can. Okay, that's alright. Well, that messed up my typing. Oh well. Oh my god, that is terrible. Yeah, that messed up big times. Let me pause. Okay, fixed. X squared minus 4x plus 1 is the question, and I will do a table type of values. And so you do something like this, and you write that x and y, and you write all the possible value of x. I think it's up to 5. It is. And you calculate the y value. So for -1 is a 1 plus 4 plus 1, which is 6. For 0 it is a 1. For 1 it is 1 minus 4 plus 1, which is minus 1 minus 4 plus 1 is plus minus 2. 4 minus 8 plus 1 is -3. 3 is 9. This is -2. Then it should be 1 and 6 if I'm... Yeah, quadratic have a very good trend of repeating itself. So sometimes you can do this. Most of the time you can do this. Now, you've got this value, and you just plot those 6, 7, yeah, if I can count, 7 points onto that graph on your answer booklet. They will give you answer booklet graph, and draw it onto that graph and find the 2 points that it intersects, and use the graph to estimate the coordinate by just looking at where those 2 lines are cut and where they intersect will be sufficient. They're quite lenient on how accurate your plot is. As long as it is in the close proximity, they will give you marks. So do not use all your time by just trying to count squares. You need to do it accurate but fast, because you don't have a lot of time. Okay, part 2, show algebraically that where the curve intersects is this graph. Okay, so typical. We've got a y equals equation and another y equals equation, which means you can make it so that those 2 are the same. So x squared minus 4x plus 1 is equal to 1 over x minus 3. 1 over x minus 3. What? Okay. Okay. I can't type today. Now you can multiply both sides by x minus 3. Since x cannot be 3, doesn't really matter, because you're not multiplying anything by 0, since x doesn't exist as 3 in that graph. So you can do it so x minus 3 times x squared expand this thing, and you will get x cubed minus 4x squared plus x minus 3x squared plus 12x minus 3 is equal to 1. And so you rearrange the 1 to the left and get that the answer is x cubed minus 4 minus I number locked my computer, really, 7x squared plus 13x minus 4 is equal to 0. And so now with this equation, and we verify that it is the same as this one, and it is. Okay, so now we have showed what this equation come from, and now we continue to part 3, the last part. Use the fact that x equals 4 is a root of x cubed minus 7x squared plus 13x minus 4 equals 0 to find a quadratic factor of this and find the exact value of the other two roots. Now, this is essentially factorizing a cubic. So use x equals 4 is a root. So we know that x equals 4 is a root, so there's a factor called x minus 4 and the factor of quadratic is equal to fx. And now we need to find the quadratic. How? Okay, I can't control my computer today. Okay, so what should we do right now is that we need to do a factorization. So you do copy this and you do a factorizing exercise, which is always fun. You do x minus 4 on the left. Because we know this is a factor, we can divide this by x minus 4, and you know that this is x squared times x is x cubed. X squared times negative 4 is negative 4x squared. Can just about make out my disgusting handwriting. So 7 minus 4, negative 7 minus negative 4 is negative 3 x squared plus 13 x. Excuse my terrible handwriting, I'm so embarrassed. Minus 3x times x is negative 3x squared, and this times 4, because it's double negative, it's a positive, so plus 14x, 12x rather, and that would yield you an x plus minus 4, and that remains a plus 1 because there's only one x and one negative 4. And so we have factorized this term using terrible handwriting. We know that the quad is equal to x squared minus 3x plus 1. Now, here comes the problem. How do you find the exact value of this equation? Well, this is a quadratic. We have something called the quadratic formula that you can use, but the thing is you don't have a calculator, so how do you find it? Well, it did say use exact values, so we aren't going to factorize anything. So first, let's do negative b, which negative 3, which is 3 plus or minus the root of, I'll add the minus later, the root of b squared, which is 9, minus 4ac, a and c is 1, so minus 4, divide by 2a, which is 2 in this case, plus or minus that. So the answer will be 3 plus or minus the root of 5 divided by 2. Okay, so this is the answer, and you can just leave it like that because mark scheme allow that. And if you want to be secure about it, you can write separately 3 plus root 5 over 2, comma 3 minus root 5 over 2. That is the safe bet. Now, we found the 2 roots, and we'll find the quadratic factor, and so we have finished this paper in 1 hour and 27 minutes, which leave you 3 minutes to revisit and revise. Of course, there are a lot of unnecessary step and editing that I have to do, which means actually this paper should leave you roughly, if you're fast about it, half an hour to 45 minutes of revisiting time to check your answer. And once again, checking your answer is extremely important in doing any math test. So I will wish you good luck on your mathematics test and exam, and I will see you again on the next paper.